Section 5.3, Exponents. Exponents are a shorthanded notation for repeated multiplication. For example, if we look at 5 to the 4th power, this is 5 times 5 times 5 times 5. 5 multiplied by itself 4 times. The 5 is known as the base of the exponent, and the 4 is the exponent. Here are some naming conventions. Squared means raised to the 2nd power. So if we had, for example, 3 squared, the base is 3, the exponent is 2, and this means 3 times 3, which is of course 9. Cubed means raised to the 3rd power. So for example, 4 cubed would be 4 times 4 times 4. Higher powers are simply named by using the number. So for example, we would say that this is 7 to the 10th power, and this is 10 to the 5th power, and things like that. Example, compute 2 to the 3rd power, or 2 cubed. This thing means 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 is 8. So the answer is 8. Exponents always apply to the object immediately to the left of it. Example, compute negative 3 squared. Negative 3 squared. We have 3 symbols. The exponent here, if we look immediately to the left of it, we have a 3. The negative sign is not included with that 3 because there are no grouping symbols to tell us so. Negative 3 squared is negative 3 times 3, which is negative 9. Example, compute negative 3 squared. This time we have a lot more symbols. If we look at our exponent and look immediately to the left of it, we have a parentheses. This tells us that this exponent applies to the entire parentheses. So negative 3 squared is equal to negative 3 times negative 3. Negative 3 times negative 3 is positive 9. These two examples are very important because students mess this up all the time. So think about this and remember, exponents apply to the object immediately to the left. There is a special case of exponents, which is that raising numbers to the 0th power gives a 1. Example, compute 6 to the 0th power. 6 to the 0th power is equal to 1. This number can be a lot of other things. It could have been 7 to the 0th power. It could have been a 15 to the 0th power. The only exception is that we do not consider 0 to the 0th power to be 1. That one is considered to be undefined. The decision that 6 to the 0th power is equal to 1 may seem arbitrary, but these types of decisions are always built around patterns and ideas. So let's think of another example with smaller numbers. 2 to the 1st, 2 to the 2nd, or 2 squared, 2 to the 3rd, 2 cubed, 2 to the 4th, and 2 to the 5th. Let's calculate these values. 2 to the 1st is just 2. 2 squared, 2 times 2 is 4. 2 cubed, 2 times 2 is 4, times another 2 is 8. 2 to the 4th turns out to be 16, and 2 to the 5th turns out to be 32. So as we move to the right, we can see that at each step we are multiplying by 2, so that 2 to the 6th will be 32 times 2. Now if we reverse these arrows, start coming back this way, what is the relationship between the numbers? 32 down to 16 is dividing by 2. 16 down to 8 is dividing by 2. 8 down to 4 is dividing by 2. 4 down to 2 is dividing by 2. So if we go one more step this way, it seems reasonable that we divide by 2 again. 2 divided by 2 is 1. And now let's go to the top line. We can see that the exponents are increasing as we step to the right by 1. And so what would be the one that precedes this? It would be 2 to the 0. Then we have 0, 1, 2, 3, 4, 5 as all the exponents. And so this relationship here gives us the reason why it's reasonable to say that 2 to the 0 is equal to 1. And this pattern works with all numbers except for 0. 0 to the 0 is undefined. Section 5.4, Order of Operations, Part 2. This is the full list of the order of operations. We start with parentheses and other grouping symbols and work inside out. Then we have exponents, multiplication and division done left to right, and addition and subtraction done left to right. Example, compute 4 plus parentheses 3 squared minus 6 times 2, indicating the steps. Before we actually do this calculation, we want to think through what's going on. We see that we have some parentheses, so we're going to have to work inside the parentheses. Inside the parentheses, we see exponents, we see subtraction, we see multiplication. And so we will first do the exponent, then the multiplication, then the subtraction, all of this doing inside of the parentheses, and then there's still this extra addition step on the outside of the parentheses, which will have to come last. At first this may seem complicated, but after doing a few examples, you begin to get some intuition about how it will work. Okay, so here we go. Inside the parentheses, we're going to do the exponent first. 3 squared means 3 times 3, which is 9. And we're going to indicate this P-E, parentheses, and then the exponent inside the parentheses. What's next? 9 minus 6 times 2. The 6 times 2 is multiplication, so that happens next. So we're inside the parentheses, we're doing the multiplication. 4 plus 9 minus 12 is inside parentheses, so 4 plus negative 3. And we did subtraction inside the parentheses. Notice that I'm keeping the parentheses as a grouping symbol so that I don't have the plus sign and the negative sign running side by side. We never have two arithmetic symbols side by side. 4 plus negative 3 is 1. And that last step was an addition step. Example, compute, parentheses, negative 3 squared plus 4 minus 2 times 5, indicating the steps. We're going to go through the same process as before. We see parentheses here. We see inside the parentheses an exponent. We see an addition. Outside of the parentheses, we see a subtraction. And we see a multiplication. So we'll look inside the parentheses first, do all those parts. And then we'll go outside of the parentheses and then do those parts. Negative 3 squared plus 4 minus 2 times 5. Inside the parentheses first, I'm going to write everything else. We have the exponent coming before addition. Negative 9 plus 4. The reason why this is a negative 9 is because the exponent is next to the 3, and the 3 is not grouped with the negative sign. So this is negative 3 squared, as opposed to negative 3 being squared. Parentheses, and inside the parentheses we did the exponent. Next is going to be the addition step inside the parentheses. We can see that the parentheses here are a little bit extraneous. The negative sign does need to be grouped with the 5, but if we drop the parentheses, it would still be grouped with the 5. So for the next line, I'm not going to draw it again. And we'll do the next step in the order of operations, which is the multiplication. Negative 5 minus 10 is negative 15, and that's a subtraction.